So the Gaussian surface usually ends up being a sphere or a cylinder or some sort of box. So the sphere, let's say we have a sphere. Here's a drawing of a sphere. We have cylinders. They look something like this. And then a box would look something like this. Not the best artist, but you get the idea, okay? So if we call this length L, this has a radius R, and this has a radius R. We want to just review the surface area and the volume of these things, because I find people tend to be rusty on these. So the volume of a sphere, volume sphere is, well, let's just make a circle there, is 4/3 pi r cubed. The great way to know if you're dealing with the volume of our surface area is there should be 3 dimensions for the volume, right? That makes sense. And then the surface area is going to be 4 pi r squared. Fun fact, this is the derivative of that. And you can think about why that's the case if you want to. For the cylinder, the volume of the cylinder, that's going to be pi r squared times L, meaning you're going to get pi r squared, that's that, right, times your height, which is basically just base times height, so times L. Okay, it gets a little bit more complicated when you do the surface area of the cylinder. That's going to be these surfaces, right? Those are pi r squared, but there's 2 of them, so you'd say 2 times pi r squared. But you also have this area here. And the way that you calculate that is you want to say, okay, well, we have base times height, okay? So that's going to give us, we have the top and bottom here. So we just need to add on plus 2 pi r, that's the base, right? That's the length of a circle, times L. So when you write this all out, the surface area of your cylinder is going to be 2 pi r squared plus 2 pi r L. And we're going to use parts of this depending on what the problem is, okay? But it's important to sort of know that. For a box, the volume's easy. The volume's going to be L cubed. Okay, once again, here you're looking for 3 dimensions. So this is obviously 3 dimensions. This is obviously 3 dimensions. Slightly less obvious is this times this gives you sort of a cube of sorts, okay? But there's 3 length variables, okay? For the surface area of the cube, you once again have 6 sides times L squared, which is, L squared is just 1 surface, and we're assuming this is a cube, but it doesn't have to be a cube, in which case you'd have to calculate each side individually, okay? So just generally, we have volume for a sphere and surface area for a sphere. We have volume, volume for a sphere, surface area for a sphere. Volume for a cylinder, surface area for a cylinder. Volume for a cube, surface area for a cube. But the key thing is being able to figure this out in your head and visualize what each thing is.